so I'll never weigh it down. Welcome to my presentation on WMI. We'll get right into it. Okay, so who am I? Enzo, you probably know that, but if you don't, I'm the head of research. I also do mentorship. Shout out Jake. And I'm also a CCDC. Shout out Philip. Oh, Philip's gone. And Robert. And all the people in the room that are CCDC. What?
Hey, where is that picture taken at? Where was that from?
This was at the lovely Wickham Farms. Okay, we did a social event there, and we went like, what did we even do? We did like a corn maze and stuff.
Donuts.
It was great. Good times right there. Maybe we'll do more
social events.
More social events, I say.
Yeah, dude.
Anyway, I like Windows offensive security thing. Manuel hates it, and of course, I hate Among Us. I wish Philip was here to see that, but I made that for him. Okay, so getting right into it. What is WMI? You've probably heard of it before. It stands for Windows. Shut up. It stands for Windows Management Instrumentation. It is a tool, service, whatever you want to call it. It exists on all Windows systems, and it runs by default. Used generally by sysadmins, programs. It's quite crucial to the operating system. It is used to manage systems, and it is really, really, really good at finding system data and information. I'll get into this further down. There are almost 8,000 WMI classes installed by default on Windows. It's a lot. I'll show you some in my demo. And it's also very versatile when it comes to attacking and defending. So to my red and blue teamers out here, I got you both. I'm going to be going way in depth into all that stuff at the end. Quick notes, I guess. Reconnaissance, or this for red team, reconnaissance, persistence, privilege escalation, code execution, antivirus, VM detection, like basically do anything. And then blue teaming, you can basically make an intrusion detection system, which I'm also going to do later. It's pretty cool. Okay, so starting off, I throw a lot of terms out, so just generally. Okay, so WMI data is made up of these things called managed components. And a managed component is basically, I guess, any operating system item that you can think of. So a running process, a disk partition, a service that's installed, a registry key, I don't know, trying to think of other things. I'll show you guys later all the meta classes. Anyway, when I reference WMI objects, I'm going to say that a lot. Managed components are also WMI objects. Just a quick note. So, interacting with this data, this WMI data, there are 5 types of ways to interact. So the first is consuming. So this is when you, the user or program or anything, is utilizing these specific data or invoking objects. So that's where the execution comes in. We'll talk about that later. Querying. This is when you're searching for fine-grained data. When you're searching for connected devices, USBs, anything, logical processors, amount of RAM, like anything. You're basically querying these classes for information. Populating is how the data is obtained. So 2 main ways. Temporary is when you start a session and I have a whole demo on this later. Basically, temporary only lasts in a session, and persistent is when you establish your own classes for WMI. Also, I'm going to talk about that later. Structuring. This is basically how WMI data is structured. I have a quick slide on that later. And transmitting is what everyone wants to know, how to do things remotely using this. So also have slides on that later. Oh, damn, it's bright. So how is it organized? So WMI data is organized into classes. Some are very well documented, like Win32 process, and then others are very random. Like I said, there are 8,000. I'm not going to document all of them. However, every object is queryable. Every object you can find all of the information on it. So it's not so much of a downside that everything is not documented. And also, a WMI object is an instance of a WMI class. What? Can you believe that? Object-oriented things. And also, WMI classes are organized into namespaces. Go.
Now, this might be a premature question. Is this more of like a C# thing that you can query these? Is it just literally a command line tool? Like, or is
I will go into all of it. You're
Go
good,
into-
Tom.
okay.
You're good. There are many ways to interact with WMI. As I was saying, it's all organized into hierarchical namespaces. So, by default, root is the head of everything. This is where everything is kept under. This is where you add things. And if you, maybe I say it later, but if you don't specify anything when you're creating a class or you're querying a class, it goes to CIM v2. That's by default. So say you're querying an object, you go hostname, root, sim v2, win32, sound device or something. I don't know. I'll show you guys how all that works later. So I'm just gonna give you a quick high level architecture. I found this cool diagram. Literally basically says everything. So let's start with client side. These are all the things that you can use to interact with WMI. So there's a Windows default tool. You go to CMD. WMIC.exe exists. I'll go in depth on that later, actually. PowerShell, there's a bunch of commandlets. Windows scripting host, so that's your Visual Basic script or your JScripts. That's WBEM test.exe. That's a GUI application. You can do C, C++ via the COM API, or you can do C# using system.management. WinRM, you can also use, I'll talk about that later too, and WinRS is part of WinRM. So, also organized in here. So, to query data, I don't know why the line is connected to that stuff. It can connect to all of them. So the language is called WQL. That's what you use to query WMI data. Down here, some of the important DLLs that are involved. This is the whole WMI service. So it's WINMGMT. And they also didn't include RPC or remote procedure call service. That's also needed when you're running WMI. Up here is the remoting things that I'll go into later. DCOM and WinRM are used for remote stuff. And this is where the information is stored. So the WMI or CIM repository, I'm going to talk about that a bunch. And MOF files and objects. I'll go into all of that. Take a drink. Also, if you have questions throughout, please let me know. It's going to be a lot. Okay. So, as I was saying, you want to query information. You want to find out these sort of things. You want to find out whatever information you're trying to find. WQL, WMI query language. It's literally built on SQL, so the syntax is basically identical. Select, this is just a select statement. Select star from logical disk where the file system is NTFS. Just an example. Very, very similar. So here's some examples of screenshots of me running things. So there are three main types of querying a WMI object. The first is an instance. So this is a static, or actually no, I guess it could be determined dynamically as well. So I cut it off on the top screenshot because it was so much output. But say I was like, okay, I want to know the names of all Windows services that are running, and then you can query that. Next one, there's also, you can use the searcher function, the WMI Searcher. So here I do find all the Windows startup commands, and you can see all these, Spotify and Razer Synapse and stuff that are running. Down below, get CIM instance. I'll talk about CIM. This, I wanted to know what all of the Windows logged on users were. So those are just three ways of querying an instance of a WMI object. Philip put this in my presentation. I don't really know what it means. But I'll also, so the second way to query a WMI, class or object is called an event, and I have a demo for this later, so I'll hop into that later. And the last is meta, and I'm going to show you guys this a bit later too. Basically, you are just querying all the classes that exist. So here's a little screenshot of it. I'll scroll through the list later, but literally anything conceivable that you can think of is here. So now, interacting with WMI, all of these tools. So Of course, PowerShell, the go-to, probably what you want to use if you're planning on using WMI. It's very customizable. You can basically do whatever you want, set all your parameters. PowerShell is probably the number one on that one. WMIC, it's deprecated. However, um, it comes with pre-configured modules, so it's not as customizable, but it comes with a lot of modules, so you can still do a lot with it. It's just not as customizable as the PowerShell commands. And if you note, see how some of these are like get WMI object and get CIM object and or class instance, whatever. These are all the newest, I guess, version. And I don't. Clev was talking to me about it the other night. He said that the WMI object stuff is all being replaced by the sim commandlets. I think I talk about this later as well. The sim is like the new wave of WMI. Again, unconfirmed on that. I don't know if it's. He said it's gone, but I don't know. Oh, and okay, so WinRM. This is just an example of someone starting the Notepad thing with WinRM. Just quick, WinRM invoke, Win32 process, Notepad, something like that. Here's VB script and JScript, so those scripting host languages. Someone's querying Windows 32 schedule jobs, just like that. Pretty easy. C and C++, practically similar. I just took a screenshot from MSDN. You can go into it. C#, as I said, system.management. So now some GUI tools. So WBEM test is terrible to work with. It is just so ugly and just hard to find things. I was like searching for process properties for a while and it's just terrible. So there's this thing called WMI Explorer, which basically has all these nice lined out things. It shows you the classes, it shows you all of the properties and methods of each WMI object. Very clean, and it has dark mode. Whoa, cool, epic. Configuring WMI settings. So there's a register key, oops, right there. And also, if you want to configure WMI control, settings control, like who can use it, who can write to it, that sort of thing, you can do it in MMC snap-in. So, everyone wants to know, how do I use WMI remotely to, fuck up my blue team's, all their boxes, So, what you need is valid credentials, of course, every Windows thing. It's always valid credentials. Second thing is you need a privileged account. However, this is only set by default, and you can change it to let an unprivileged user use it. So, there are two main ways of using WMI remotely. DCOM, which is over TCP port 135, that's distributed component object model, and WRM, which is probably what everyone knows. These are TCP ports 5985 and 5986. Oh, yes, newer commandlet. So as I was mentioning earlier about CIM, so Windows recommends is a weird word, WinRM over DCOM. So if both the WinRM service and, oh, this just popped up. If both the WinRM service and the DCOM service or RPC service are running, it will use WinRM first. Okay, so this is where the sim stuff comes in. However, in the get WMI object, all of the invoke WMI methods, it will use DCOM instead. So just wanted to note that quickly. So quick note on DCOM as well. If you want to set permissions for this, blue teamers pay attention. You can configure all the settings and ACLs using this stuff right here. So access permissions, you can edit the limits, and then this is where people can use it. Launch and activation permissions, you can set limits for that too. Okay, so I have 2.5 demos right here, and I'll show you guys that stuff, and then we'll move on to the next few slides.
See if he can do it without leaking anything.
I can't promise anything.
John said the thing.
He said the leaks word. Prepare for bright screen.
Is this considered a leak, John?
I think it is.
Yeah, I'll say yeah. So
Basically, yeah. I would say yeah. Okay, where is it? Remote desktop.
Somebody's gonna join the stream. Start
Okay.
Zoom. Watch out. You're gonna get stream sniped.
We're gonna let this start up. Yours is here. Also, extra notes in here. So I don't forget anything. I wrote a bunch down. Okay. Okay. Just try this. Is this big enough? Does that look big enough?
give it one more enhance.
36. Boom.
Well, that's thick, but yeah,
It's
it works.
very big. Well, we'll have to do.
Size.
So I have these two VMs right up here. So I have a server and a client box. Doesn't really matter. Just doing that for what it doesn't matter. It's just set up two different. Wow, that's really small. Hold on. Hold on. Wow. What did we set it to? 36? Okay, so as you can see here, I have the host name set to WMI client, and if you look at all the net users up there, that's all the users on the account. So what I'm going to be doing is just using first dcom WMI to add a new user to this box. Actually, I'll give you another one. As you can see, current, just like that. So what will we do? What we will be using here is the Invoke Wmi Method. So we do Invoke Wmi Method. We have our computer name, which is WMI client. The class will be a Win32 process. So I'm probably going to be doing cmd.exe and then passing parameters to that. So we want to use the create function of Win32 process. We're invoking that. So we are basically creating a new process on the remote machine. And now we have argument list. And this is where we put what command we want to run on the remote machine. So someone give me a user.
Potato.
Potato? Potato. The Mac guy. The manual. Okay, so that's our command right there. We're adding a new potato user. Should work. Let's see. Okay. Well, this is awkward. Hold on. Oh, I'm an idiot. No, wait. Am I an idiot? Okay, I'm slightly an idiot. My PC server is not available.
Is it running?
Annoying. Oh, hold on.
Head is down.
I have no internet connection for some reason. Alright, technical difficulties. Sorry, guys. Bear with me for a second. I'm not really sure why this isn't working.
The demo gods.
I literally tried it earlier today and it was working.
Yep, that's how it works, Chief.
Man. Do I have no connection whatsoever? No, I do have a connection. Oh man. Everyone just, the demo gods hate me.
What is supposed to be happening here?
Well, nothing right now, Chief.
Yes, exactly. Nothing right now. Maybe. Oh, I can't restart it. Nice. Yeah, it's running by default. Take note. Maybe it's not running on this one. Whoa, that's so small.
He's back.
No, it's running.
like heckle him.
Yes, give me your heckles while I'm screwing up my presentation.
Uh, Bill Gray's eyes flags.
Maybe it was the firewall.
It's always the
Oh, there we go. Boom. Okay, yes. Welcome back. Okay, so if you see this and you don't see an error message, return value 0. So we pop over to the client box, run the little net user command, boom, potato, remote code execution right there with the invoke WMI. Yes, not done yet though. Thank you. So we're also going to do WMIC as well, just a quick show you that this still works too. So it's just a /node, and then you put your client name or your IP address, whatever you want. Process call, create. So this is what I was talking about with the modules. So it has the process module, but it doesn't have every WMI class. However, you can do this thing remotely. So what I'm going to do is just do another local group administrators. What was it? Potato. And then I'm adding a potato to the admin group. And you should see method execution successful. Return value 0. Hop over here. Net user potato. I spell potato right. And boom, part of the admin group, just like that. Okay, so quickly, I want to go over the WinRM stuff as well, just quick. So as I was talking about earlier with the CIM commandlets, so that I have WinRM running on this machine, so it's accepting or sending and accepting WMI connections. So when I use the CIM commandlets, it will be using WinRM for WMI. So I'm just gonna have a variable here called sim session. Create a new sim. Oh, froze for a second. Have our computer name, which is WMI client. Oh gosh. And then we have a credential. So Enzo is my domain. And then I'll just use administrator. And then we have authentication, negotiate. So this is just WinRM setting up stuff right here. Okay, hold on. Did I spell it wrong?
Is there supposed to be a dash or something?
Oh, thank you, John. GG
Always a
froze.
dash.
Alright, so yes, I'll just establish our session here. And now when I run, gosh, did I not write down the second part of the command? Maybe not. I think I have it pulled up here though.
Use your big brain.
Don't worry, I already remembered it. I knew it was going to mess up. So here I have just enumerating shares on a remote machine. Check that out. So Win32 share, just for example, it's using the sim session that I made as the variable. And boom, you can see all the shares on the remote box. Just like that. There's a little secret share. What? Who would have known? Okay, and one more thing that I wanted to show you guys was that meta stuff. So, God, did I write it down somewhere? Yes. Object, query. So this is where we have our, if you have a custom query that you want to enter for, reconnaissance or something, get WMI object or get CIM instance, that sort of thing. So here, we're just going to do get star from meta class, where class __ class like, and we're just going to do the Win32 classes because there's more, but this is just easier to see. Just like that. Run it like that, and yeah, as you can see, I'll just cancel it. Basically, anything you could ever want in a Win32 related class, it's here. There's so much. And this is just the Win32 classes. There's still everything besides the Win32 classes. So, a lot of places to hide and such not. Okay. Back to the slides. God, white light. Sorry, everyone. Share screen. Safari. Present. Okay. Does it still work? Yes. Okay, so the next big thing, this is a lot of what WMI is known for, is called WMI eventing. So basically, you can set up these things to respond to asynchronously, so off keyboard, to events. So there are three parts to an event, and me and Philip talked about this in our advanced Windows thing. So there's the event filter. So this is what you're filtering for that you want to monitor. So I'll go into that a bit later. The consumer is the action that you want to take as a result of the event filter occurring. The event binding is just binding or registering. They call it registering it together. And as I was mentioning before, there are two types. The temporary is when, say, you create an event in a PowerShell session or something like that. As soon as you quit out of the PowerShell session or something, it's just gone. So it's not static. And there's also persistence, is when you make your own WMI class and you store it in the CIM repository. So a little more persistent. I'll talk about that as a red and blue teamer later. Did it freeze? Okay. So going right into the event filters here. So there are two types of event filters. So there's an intrinsic event, which uses WMI classes, objects, namespaces. An example is an invocation of a method. So a method was called by a WMI object. The downside of using these is that there is a polling interview that you must set for all of these classes. And this applies to all WMI classes or objects. If you say a malicious adversary comes in, they run their command, and then they clean up quickly outside of your polling interview, you will miss it. So your event will miss it. Extrinsic events fire immediately. There's no polling interview. An example of this is a registry key change event. So a key was changed, a value was changed, something like that. The downside is there's not that many extrinsic events. And you can look all those up if you want to. So as I was mentioning, this is the action that takes as a response to the event occurring. So here are the main types here. There's a log file, a log file. You can execute a script, write to the event log, send an email, or command line execution. The binding, of course, you're just connecting those two, and then your event is running. So here's just a quick PowerShell of that. So back to the demo. I'm going to be doing a little small demo here for this too. My last demo, I promise. Share. Okay. So, hop over here. So I'm going to pretend I'm a blue teamer on this machine. God, I've been talking for too long.
Have a coughing fit on stream again.
Dude, I'm doing the most.
Quick. Kill.
Okay. Let's see Okay, so I'm a blue teamer on this box, and I want to set up a WMI event. I'm going to just do PS exec because it's very easy to see. I'm going to set up an event to show if a PS exec service is installed. So, three parts. Remember, we have our event filter, event consumer, and event binding. So I'm just going to type these out and have more water. Let's see here. Okay. So we have our WMI event. This is where our query will go. So star from, oops. Yes. So do select star from instance, creation, event. So if an instance of a WMI object is created, that's the sort of event we're looking for. Let's see, okay, so polling interview within 10 seconds. So it checks every 10 seconds. Where your target instance, let's see, oh God, I can barely read my handwriting, is a Win32 service. So obviously the service being installed. And target instance dot name and the name of the service being installed is PS-exe service. Boom. Now we're going to set our consumer. So
You want to enhance that a bit, Enzo?
Yep. So small.
Thanks, sir.
So for our action, I'm just going to do like an echo statement. Just like that. So that's the response to the event being fired. Now I'm going to bind them together. Oops. So the source identifier is just what you want to call the binding. So just any names, whatever name. And the action is, of course, our action. So, hold on. It appears I messed up on my query. Just copy it. Boom. Okay. So now it is polling for this event to occur. So on this side, I'm the malicious adversary. I have my PS exec here, just logging in and starting command instance. Oh, boom, just like that. And now we wait 10 seconds. Oh, well, it popped up right away. So you can use your imagination here. I just wanted to show a service being installed. Actually, I can show you. You guys probably know, but oh yeah, you're no way you can see that. But anyway, it'll do that once, and say you set one for it being uninstalled, you can have set something like that too. So that's my demo there. Transition back to the slides one more time. Okay. Clicker thing. Oh man. It's not working anymore. Oh, there we go. Okay. So quick notes, I mentioned them earlier. So MOF, CIM. So MOF is managed object format. These are the files that are WMI classes. So they have C++ like syntax. If you wanted to create your own, you just look it up. Pretty simple, self-explanatory there. CIM, Common Information Model. This is just a standard, and Windows just started, I guess, introducing that name for their WMI stuff. So it's just a new naming convention. And of course, I mentioned it earlier, the CIM repository is where WMI information is stored. So as an attacker, quick recap. So as mentioned, it is installed and running by default. So obviously good for us. Persistent WMI events. So this is when you create your own classes, that sort of thing. They all run as system by default, and can even be done in a way where no payloads touch the disk. So it's fileless. It completes, or it is 100% just in the WMI classes, and you can set up eventing in that sort of way. I put a link in the end if you guys are interested in looking at that. Every OS action can trigger and event something. It's super highly customizable, and it's great for recon, as I was saying. Good for VM detection, AV detection. So if you look at this right here, so here I queried my BIOS in the VM and looked for VMware string, and I returned that right there. Boom, just like that. In this screenshot, it's looking for an antivirus product, and it sees Microsoft Security Essentials is running. Obviously, code execution, starting processes, running commands, as you guys saw. Creating WMI providers. So this is creating your own classes and objects. And I probably missed more. So obviously, gonna go with our blue team. Thanks, Philip, for the meme. WMI eventing, as you guys seen, it's very, very customizable. You just have to use your imagination and have some time. Also, auto runs. Shout out to auto runs. It can detect all that sketchy WMI stuff. I'm gonna go into some attack detection. So, say red team is using WMI for resistance, consistently an instance creation of event. If you have one for event filter and event consumer, those must be in every single one for WMI eventing for persistence. So just have an event on there and you can watch for that stuff. Say a red team stores attacker data in the WMI repository. I've seen this with a C2 where all the information is stored in there and pulled from the sim repository. So obviously have a modification event for class modification. Say, and it doesn't have to be WMI related. Say red team is changing registry values. You can set an event for registry values being changed. Simple as that. It can become sort of like a cat and mouse game where red team's using WMI and setting events, and blue team's setting WMI events, and then it just kind of is weird, and whoever can get on top there. But it's good stuff. And some mitigations for attacking. So if remote WMI is not needed, change the decom port, block it. If WinRM is needed, obviously, or not needed, block the port or stop the service. As I mentioned earlier, decom config has WMI permissioning. So if you go to your component manager, check that out. And WMI, decom, and WinRM events are all logged to the Windows event log. So if you need that, quick research notes here. So obviously, I base most of my stuff off this white paper here if you want to learn more about it, and a bunch of stuff down here. Obviously, check the Microsoft Docs. It's full of information. This one right here is the file list C2, all done through that. Very interesting. And then some tools that I've used before. I've used Impackets, WMI exec, and CrackMaps execs. I don't know what they call it, but they use WMI. I've used both of them. They work pretty well. Here's a WMI, I guess C2 implant. And then for blue teamers, WMI monitoring software right there. And of course, auto runs. So that was a lot of information and a lot of talking for me. So you guys talk. Ask me questions. Someone's got questions, right? Anything? Twitch chat? Oh, it's just that. No questions for me?
That's just powerful, man.
It is. I agree. Well, thank you guys for listening and bearing with me. It was a lot. Spent a lot of time on that. So next up, we're gonna go